welcome everyone, and thank you so much for joining us this week. We're very excited to have Hanne Digre joining us from Norway, and we're very excited to be hearing about what she's going to be sharing from Scale AQ. I'm going to hand over to Hanne.
Hello everyone. Hello. Yes, my name is Hanne Digre, and I'm working as Chief Sustainability Officer in Scale. Today I want to talk a little bit about circular solution for the aquaculture industry, and mainly focus on a project that is just started and that we will implement in our company. It's about circular solutions and technology for plastic equipment from the aquaculture industry. So, yes, first I will introduce Scale AQ, what kind of company we are and what we are doing. And I will also say a little bit on how we work with sustainability. And then I will present the project, CIRC, that we have called CIRC AQ. And it's a funding, it's funded by a green platform project here in Norway. So it's a collaboration between different funding organizations. First, I will show you a movie about Scale, so you can have a little bit impression on who we are. Yes, so we are a technology supplier for the aquaculture industry, and we provide products and solutions and also services for the aquaculture industry worldwide, and we are represented in all the salmon farming countries, as you can see on this slide. So we are based, we have our main office here in Norway, as you can see on the map here, but we have also facilities in Vietnam. We have offices in Tasmania and in Chile and in Canada, both on the west and east coast, and we are also based in Iceland, Faroe Island, and UK. We are about 900 employees. And we have about around 40 years of experience, and our main focus is salmon farming. So here is some of our technology that we provide. We say that we deliver equipment from all along the entire value chain when the fish are alive. So from hatchery to the slaughtering. So we deliver pens, all the nets below the surface here. We have mooring systems, different kind of sensors in the nets for surveillance of the fish behavior and the fish. We have also feeding systems, barges, which operate the whole fish farming facilities. We have also working boats, services, deliver software, and we have also deliver equipment for closed aquaculture systems. So I have also another movie to show you, just maybe you are, I'm not sure how familiar you are with the aquaculture industry, but here we have a video also showing some, yeah, you can see key key numbers and how the facility is operating. So here you will see the different pens, and there are quite big pens. They are more than 30 meters deep, and when we compare it with like here you can see the flight, it's quite big. And here is about 200,000 of fish, and the whole facilities with all this 8, you need to multiply it with like 2,000. So it's about 1 to 2 million fish in fish farm like this. And here you can also see the feeding systems, how it's been operating. And here is the feeding pipes. This is also made of plastic. Almost all the equipment in this pen is also made of plastic, both the nets and the floating collars. So it's a lot of amount of plastic in this pen. So here you can see the surveillance of the fish, and also how it's been the feed. Yes. So we are as a global technology supplier. Sustainability is part of everything we do, and we have defined goals and actions, which we have divided into 3 main areas. We are both focusing on our own value chain, where the goal is to reduce our climate footprint and increase the circularity in our value chain, and of course with our products and solutions to contribute to our customers that to make a more sustainable aquaculture industry for the future. We have also picked some of the UN's sustainability goals, where we have actions and KPIs and goals. So there are challenges today that need to be solved for the industry to grow, and some of them are listed here. As you can see, in Norway and there are big challenges regarding sea lice. The mortality is too high, and we need also to access new areas more exposed. So we need better control and documentation to further develop the industry. And generic challenges we need to address is, of course, reducing the greenhouse gas emissions, reduce plastic waste, and improve the circularity and the energy efficiency. So there are some challenges to solve. And we have also made our sustainability strategy. We have 3 main areas where we have special focus on. We have one called the Scale Circular, which I will focus on in this presentation. But we have also technology for zero emissions and protect animal welfare. And we have also one focusing on people and interaction with society. So we started, we have mapped our greenhouse gas emissions, and we have also included both scope 1, 2, and partly scope 3. And we see that from our climate accounting that the purchase including plastic, concrete, steel, which we use in our technology, accounts for the highest CO2 emissions in our value chain. Yes. So, so that is also a little bit about, this is also like why we have, for instance, focused a lot on how we can improve the circularity in our value chain. So, and regarding the fish farming equipment, it's estimated that a farming facility with that you saw on the video accounts for 8 to 10 cages or pens, makes up more than 300 tons of plastic. And in total in Norway, it's about a little below 200,000 tons of plastic is in use in sea-based aquaculture. And it's also a study from some scientists here in Norway showed that around 16 to 29,000 tons of plastic waste comes from aquaculture facilities annually, and whereas about 37% is reused or recycled. And we want to increase this to 100%. And it's also resources that can enter circular value chains. So it's valuable resources that we need to do something with. So here's just a picture of sources of both as plastic. We have the feeding tubes, and we have the floating colors, and we have walkways, and we have also handrails and other small pipes in circle around the nets, and we have also sinker tube and also nets made of plastic material, and also buoys and ropes is part of this. So, and there are also regulatory requirements coming. It's this producer responsibility, which means that we need to report to the EU from last year the amount of equipment placed on the market, in addition to collected amount of waste. So when this kind of equipment is not being used anymore, we need to bring it into a circular value chains, so we can either reuse or repair, or also use the recycled material into new products. And there are also demands to we need to have a national minimum target for collection for material recycling, and the deadline for the implementation is by 2024. And of course, there's a challenge regarding the marine litter, and the UN Environment Program estimates that between 9 to 14 million tons of plastic end up in the sea every year. And the study in Europe shows that more than 80% of marine litter is plastics, of which about 27% is equipment from both the fisheries and the aquaculture sector. And similar in Norway, fisheries-related waste accounts for about 46% of the total amount. And as you can see on this figure, shows the different fractions of the marine litter along the Norwegian coast. So this is also, this challenge is important to address. So let's also a little bit background on why we have putting this circular economy high on our agenda in our company. It's in line with our strategy that we will become circular to reduce both climate emissions, the use of virgin materials, reduce waste, and increase value creation. We focus on reuse, life extension, and the use of recycled material into new products. We are also working a lot with environmental documentation, where we use life cycle assessments analysis. And today we have a lot of development going on, but we produce farming equipment also from recycled plastic materials. And Scale is also the head of the Green Platform Project CERT AQ, which I will present a little bit from. The work started for two years ago. First we had an initial project called Spare, or savings in English. And the main goal is to increase the proportion of recycled plastic in several of our products used in the aquaculture industry. We have done a lot of tests. We have quality assurance of regranulates for selected products. We have done some analysis and documentation of pilot products, and we have tested and we are doing documentation of full-scale pilot installation. We are doing this work together with our supplier Hallen Plast, and also we have done the analysis together with a research institute here in Norway called Nordner Research. So we took some floating colors that was ready to be exchanged. It had stood in the sea for about 15 to 20 years, and we made we shredded it and made regranulates, and we also made new products here illustrated by feeding pipes. So yes, so we made some testing and analysis, and here you can see here we have analyzed the reduction of antioxidants, and the job of the antioxidant is to like sacrifice themselves to secure the life of the polymer, and in our case the HDPE is also protected from UV light degradation by using carbon black as a pigment to protect from sun radiation. The primary phenolic antioxidant will protect the final product during its life in an open environment. And the concentration of primary oxidant has been reduced with more than 40% after the initial pipe extrusion and 15 years life in the open sea, as you can see here on the bars. On these bars. The secondary antioxidant will protect the polymer when the HDPE is exposed to high heat, which is in the melt phase during pelletization and during pipe extrusion. For the secondary antioxidant, we can measure both the remaining active antioxidant, the blue bars, and the reactive antioxidant, which is oxidized, the orange bars. In this case, the secondary antioxidant, IRGAFOS 168, is also doing its job, and as we can see, the pipe extrusion process is consuming a significant amount of the process stabilizer. And approximately 60% of the secondary antioxidant is consumed when we are sending the HDPE floater to recycling. So it's important to have this in mind when working with regranulates and this and when we are also making new products of this raw material. We did also some microscopy analysis, and here on this left side you can see a pipe made of virgin HDPE. In the middle is 50% virgin and 50% recirculate, and on the right side is 100% recirculate. And the analysis shows a very good homogeneity and purity in the feeding tubes, and it's also difficult to separate these three pieces. So here are feeding pipes made of recycled material from our own floating colors. So everything you can see in the middle here, the black part of the pipes, is made of recycled material, but the outside is virgin. We have also did some environmental documentation, both on the work we are doing on life extension and the use of recycled raw material, and we see that it's significant reduction of CO2 emissions. So for the life extension of floating colors, the customer reduced its CO2 emission by 4 tons CO2 equivalent by purchasing a life extended floating color instead of a new one. And also the use of, when we are exchanging the use of virgin with recycled material, we see that about 50% reduction, 50 to 65% reduction of the CO2 emissions, depending on how much recycled raw material we use. So here is also a video regarding the life extension of our floating colors that we are working on.
Det starter jo med at kunden har en flytekrage som har pådratt seg en del feil og mangler i form av at den er gammel og utslitt. Så er det en vurdering, skal vi reparere den, eller skal vi kassere den? Eller nå har den kommet inn i en ny faktor, skal vi levetidsforlenge den?
Dette begynte jo med at vår oppdrettsavdeling så at i stedet for å sluttbehandle denne mero som ligger i sjøen bak oss her og skal opp nå, så ønsket en heller å levetidsforlenge den for å bruke ressursene bedre. Og dette prosjektet som Scale nå har satt i gang, da svarer på mange av de forventningene vi har om større bruk av sirkularitet, bedre utnytting av ressursene, og at vi reduserer CO2-utslipp fra produksjon av vårt utstyr.
Dette er jo konkretisering av bærekraft. Levetidsforlengelse av produktene vil jo si mer bærekraftig bruk av ressurser, og er i tråd med Scale sin strategi rundt bærekraft. Vi ønsker å gå fra lineære til sirkulære verdikjeder. Levetidsforlengelse sammen med økt bruk av resirkulert materiale vil føre til bedre bruk av ressurser og lavere klimautslipp.
Oppdretterne er jo veldig opptatt av bærekraft. De ønsker å forbedre seg. De jobber mye med bærekraft, mer og mer. Så at vi kan samarbeide om sånne prosjekter er veldig viktig for at de også skal kunne ta ansvar for produktene, og da ønsker Scale og kunden å ta ansvar for søppelet når det er ferdig.
Vi har hørt masse tall, gode tall, hvorfor skal vi gjøre dette? Men så tenker jeg, de tallene er viktige, men det viktigste er egentlig å tenke hele kjeden. Hvordan sparer vi ressurser? Og hvor henter vi innovasjonen og inspirasjonen fremover? Så derfor er vi her i dag.
Hvis vi får virkelig gang på dette, og vi må ha en takt både på nyproduksjon og på dette, så må vi jo ansette mer folk også, helt klart.
Yes, so in December last year, the Circular Solution for the Aquaculture Industry project was awarded a grant of about 70 million Norwegian kroner from the government's Green Platform Support Scheme. And the Green Platform is an initiative that provides support for research and innovation-driven green transformation in the business. And the goal of this project is to promote the transition from a linear to a circular economy in aquaculture by establishing and implementing sustainable circular value chain for plastics from discarded equipment through reuse, repair, life extension, and the use of recycled materials in new products. And the purpose is to optimize resource use as well as reduce the environmental and climate footprint of aquaculture, where also the vision is zero plastic waste by 2030. There are quite a strong consortium of 8 partners throughout the value chain, from the producer, supplier, farmer to recycler. So Oceanize is the recycler, Hallingplast is supplier, and we are the technology supplier, and then there are these farming companies, think about Hansen. So it's 6 working packages in the project, one focusing on the reuse, one on the life extension of equipment, and one on the use of recycled material. And we have also one on this eco-design of new products, and environmental documentation, and digital solution for traceability throughout the value chain. And also we have one focusing on piloting, commercialization, and implementation. And there are also, these are the research institute which is involved. It's OsloMet, Nordnet, Interpotion, and there are also a catapult center called Future Materials. And the products that we are focusing on is the ones that you saw on several times now on the videos. It's the floating colors, sinker tubes, the walkways and pipes between the walkways, handrails, nets, ropes, and yes, as you can see here. So the most important results which this project will generate, it has just started, so it's a little bit we are in the planning phase, but it will develop processes for reuse, life extension, and increased use of recycled plastic in new products. This eco-design for cleaning, reuse, recycling, and repair. The web-based sharing solutions for environmental reporting and documentation and traceability. And this is also an important result of this project, is there's identifying barriers in current regulations and standards, and influencing changes that need to be made to increase the use of circular solutions for aquaculture equipment. Yes, so we want to go from about 37 to 40 today to 100% material recycling in this projects. And here is just to show you a picture of what we are doing in when we are testing our equipment. We are testing a lot of our equipment in laboratory facilities here in Trondheim in the marine tank, which Sintef operates. And here we will test load-bearing structures as floating collars and sinker tubes made from recycled material. This will be carried out. So here we can simulate the waves and also there's currency in the sea. So we can make it realistic and compare it to facilities in open sea. Yes, I have just this slide before I'm finished. It's just to show you how we want to work. We are, of course, we have the fish in the middle. When we develop products, we need to always take care of the fish which are inside the nets, and so we make sure that the fish welfare is good. Also we are dependent. We need to work also the sustainability, take into account the environment and the climate and biology, and also the society and also the economy, of course. And we are working together with both the fish farming companies, the suppliers, and other innovative startups. But we also need to work together with the government and the regulations, industry clusters, and research institutes to ensure sustainable growth in our aquaculture industry. So this was the presentation from me today. So maybe there are some questions.
Thank you so much, Hanne. It's really encouraging to see all the strides and the links that are being taken to adopt a circular approach. I see we have had a question in the Q&A box saying how well do the setups hold during storms, and how often is material lost at sea?
Yeah, if you the equipment that we use today is tested under quite about 14, 15, 16 meter high waves, and we always make sure that we are not placing this equipment in sea that is rougher than it can be handled, that the equipment can handle. And of course, when we are doing this transformation now, looking into how we can reuse it and also maybe use recycled material, we need to do tests, as you saw so we always make this test in this laboratory facility and test it, how much, how strong current and strong waves can it handle, and we need to have like a safe space with under that. So there are very strict. This is very strict regulated. And the other question was.
How often materials are lost at sea? Sorry.
Oh, it's not often at all. I think maybe the main challenge there is maybe like some parts of ropes, if there are like it can be lost if they need to do some maintenance of the ropes, for instance. But there are not it's not often that this happened at all, actually. It's not a big issue, but we can increase. We need to transform the reuse, and as I said, that the material can go to material. Not the energy reuse, but to go to material reuse.
Okay.
So that's a transformation that we need to.
So to shift from to shift from sort of used materials going to sort of waste to energy facilities, and rather work them back into the same products.
Yes.
Okay.
Yeah.
Okay.
It's important for us. Yeah.
Yes. And so this may be an ambitious question, but in terms of the kind of shift to that, how long would you say, in terms of time, do you think it would be before that's a far more common practice, that sort of material is recycled for the same kind of use rather than for energy or alternative sort of downcycling options?
We are in the middle of this transformation, actually. So I think this project, this CircAQ project, is a 3-year project, and we hope that we have implemented a lot of this in this 3 years period. And in Norway, it's a big focus on this topic, just to look into the value chains and see how we can also reuse and also use this life extension, also this repair of equipment is much higher on the agenda for maybe when I started here in Scale for 2.5 years ago. This transformation has gone quite fast, I think, and it's a lot of also other companies working with this. So hopefully in 3 to 5 years, I think, yeah.
That's wonderful to hear. And you mentioned one of the examples with the floating collars, that the inside is predominantly used from recycled material, but the outside is coated in virgin material. Obviously, there will always need to be sort of some, typically there'll always need to be some sort of addition of virgin material. But in this particular context, is that due to the sort of harsh weathering conditions and exposure to sun that it has to withstand?
Well, actually, it was the feeding pipes that saw with the green virgin layer. It was the recycled material that we used was from the floating collars. Mm-hmm. But we actually on the feeding pipes we can use 100% recycled material, but actually in that case, this feeding pipes was used for subsea feeding below the surface, and it's not they need to divide that product from the pipes that is used for the surface feeding, because there are some issue regarding actually for the employees' safety, because it generates like current or so if for the so we need to divide it. We need to have another color on this, so the people at the facility, they could see, they know what was used for the surface, the below the surface, the water feeding, and what feeding pipe they could use for the surface feeding. But you can, for the feeding pipes, you can use 100% recycled material.
Okay. I see. I see we are approaching our end time of 12. But I wonder if you could maybe expand a little bit. Sorry, just to all those who are still on the call and those who might watch the recording. If you do have any further questions, you're welcome to email us, and we'll pass those along to Hanne. But sorry, Hanne. So just maybe in closing, are there any particular challenges or sort of successes in terms of substitutions? Any other ones that you'd like to mention? Obviously, we sort of discussed the feeding pipes, but any other sort of highlights?
There are some challenges regarding the regulation and the standards, because that prevent the use of also you can use a certain amount of recycled material into some of the constructions, like the floating colors, but you cannot. I think you cannot. It's very small amount you can use today. The ratio between recycled and virgin. So we need to increase the rate you can use of recycled material, and then you need to change the regulations and the standards. So that's a challenge that we need to address and work on further on. Yeah.
I see. And are there any opportunities for using additional kinds of plastic waste that aren't necessarily from the aquaculture industry initially? So, for example, kind of so sort of other forms of plastic from sort of household use and things like that, forms of plastic packaging. Is there any potential for those to be reworked into the aquaculture industry?
No, there are a high, also no, the short answer is no, actually.
Okay.
Yeah. So you
Okay.
need to use the same material as you have in the structures, so you make sure that the quality is maintained, and you need to also know that there are no pollutions in the material that you are going to reuse. So they are really important that the quality of the material is maintained. Yeah, true.
Okay. Okay. I don't see any other questions at the moment, but you are welcome to email those through, and we'll pass those along to Hanne. For now, I think we can end off here. See, we've gone slightly over our cutoff time, but thank you so much, everyone, for joining us today. We hope to see you next week and the week after for our last 2 sessions in the series. You can find apologies for the lights there. You'll be able to find the links for those on our events page. Otherwise, you're welcome to email us and we can assist you with those. And yeah, just to close off, thank you so much, Hanne, for taking the time to present for us today. It's really interesting and encouraging to see the strides that are being taken to adopt more circular models in the fishing industry. For those of us in South Africa, the fish farming isn't as sort of it's not as much of a familiar process, but I imagine sort of for Norway and for quite a few other countries, it's a very, very established practice. So it's wonderful to hear about the significant progress that's being made there for circular models of material use. Thank you so much, everyone, and thank you again, Hanne, for your time and for sharing Scale AQ with us today. Thanks, everyone. I hope you have a wonderful rest of your afternoon. Bye-bye.